Oh, let's go ahead and just do a few more. I'm going to go ahead and solve this one. So first thing I'm going to do is subtract. Oh, I keep doing that. Sorry. So I'm going to get it equal to 0 by subtracting x to the 5th. And that would give me 0 equals x to the 6th plus 8x cubed. Now this one is to the 6th power, which means there should be 6 solutions. There shouldn't, and they don't have to necessarily be distinct solutions, but there should be 6 of them. It's going to be important in a second. So we've got 0. I'm going to take out my greatest common factor, which is x cubed, and then you have x cubed plus 8. And then x cubed plus 8 factors more. You use that special a plus b and then a squared minus ab plus b squared formula for a cubed plus b cubed. So that's the formula right there. So I'll have x plus 2 and then x squared minus 2x plus 4, because our a is x, our b is 2, because the cube root of 8 is 2. So we factored everything. This quadratic will not factor down more. So we're going to go ahead and just find all the solutions. So this first solution is actually 3 solutions since it's to the 3rd power. That means you have 0 3 times, and that's just 0. This one right here would be x equals -2. So right now we have 1, 2, 3, 4, which means our quadratic should give us the remaining 2 answers. And let's do that over here. So our a is 1, our b is -2, and our c is 4. So we have x equals positive 2 plus or minus the square root of -2 squared minus 4 times our a times our c, all of that over 2 times our a. So that's 2 plus or minus the square root of, well, that's 4 minus 16, so -12, all of that over 2. And I can simplify it, square root of 12, because square root of 12 is 4 and 3. 4 is a perfect square. You can also break it down to 2 and 2, so you have your little pairs. But this simplifies down to 2 plus or minus, there's a negative, so 2i square root of 3. So that negative under the square root is, just make that an I, and then that's all over 2. And then last but not least, since every single factor in the numerator is divisible by 2, I'm going to divide everything by 2. So I have 1 plus or minus I square root of 3 as my answer. So, and that works because, like I said, there's a common factor, so I can pull out a 2. Oops, that's not what I wanted to do. So I can factor out a 2 from the numerator, and the denominator is divisible by 2, so it cancels out. So that's why I can simplify it that way. So there are your 6 solutions. Notice that they're not necessarily distinct, but it's a helpful way to make sure that you actually have every single solution. All right, I want to skip over to this problem right here, just to review one more factoring method, because I think I've reviewed every other factoring method in the video. So this one, there's 4 terms. This time I can do grouping method, because 12 and 4, you can divide those by 4, and you'll get the same coefficients as over here. So greatest common factor of the first pair is x squared. Then I have 3x minus 1. Second, the greatest common factor of the second pair is 4, and I get 3x minus 1. I'm going to factor out that 3x minus 1, and then I have x squared plus 4. Now, it's tempting to want to factor this down more, but it's a difference of, it's not a difference of perfect squares. This is, there's addition right here. Therefore, I'm not going to factor it down more. I'll go ahead and find my solution. So 3x minus 1 equals 0. So 3x equals 1. X equals 1/3. And then x squared plus 1, or plus 4, I mean. Set that equal to 0, so I'm going to subtract 4. And then I'll take the square root. When I take a square root, don't forget there's a plus or minus. It's imaginary because there's this negative inside. And the square root of 4 is 2, so it'll be plus or minus 2i. And just to double check, it's to the 3rd power, and look, we have 1 and then 2 3 solutions.